From the given 4.42 moles of nitrogen gas, we can subtract whatever is used up. So what is left is 2.22 moles of nitrogen gas. Here is another sample problem. The production of urea is possible by reacting ammonia with carbon dioxide. In a sample attempt to synthesize urea, 643.2 grams of ammonia are treated with 1,014 grams of carbon dioxide. The molar masses of ammonia and carbon dioxide are given. From this, we need to determine which of the two reactants is the limiting reagent. We need to calculate the mass of urea that is formed, and we need to determine how much excess reagent in grams is left at the end of the reaction. To solve for letter A, we need to perform two separate calculations for ammonia and carbon dioxide following the stoichiometric relationships below. So the grams of ammonia or carbon dioxide must be converted into their respective moles, and then their respective moles must be converted into moles of urea. If you will look closely at this solution, you will find out that the mass of ammonia is multiplied by its molar mass, then by the mole ratio of ammonia and urea as seen in the balance equation. The same is done for carbon dioxide. Comparing the two calculated values, the limiting reagent is ammonia since it produces smaller amount of urea. Now, to calculate the mass of urea that is formed, we just need its molar mass. And we will use this information as a conversion factor. So, the amount of urea that is formed based on the limiting reactant is 18.88 mole, multiplied by its molar mass, which is 60.06 grams per mole. Then we will have 1,134 grams of urea. To answer the question how much excess reagent in grams is left at the end of the reaction, of course we need to know which is the excess reagent. At this point, we already know that the excess reagent is carbon dioxide. The mass of the excess carbon dioxide can be calculated if we know the amount of the carbon dioxide used up in the reaction. The amount of carbon dioxide used up in order to produce 18.88 mole of urea can be calculated by multiplying that mole of urea into the mole ratio as seen in the balance equation. Then, we will multiply that again with the molar mass of carbon dioxide. So the answer is 830.9 grams of carbon dioxide. Now, since 830.9 grams of carbon dioxide is used up in the reaction, we will subtract that from the given amount of carbon dioxide, which is 1,014 grams. The difference is 183 grams. That is the amount of carbon dioxide left at the end of the reaction. Did you know that stoichiometric reaction is applied in the industry of production? In that case, the least expensive reactant is usually used as the excess reagent, while the more expensive reactant is completely used up or maximized for the production of the target product. After going through those sample problems, I think you are now ready to answer Activity 1, Activity 2, and Activity 3. To wrap things up, please supply the needed terms in this paragraph. These are the answers. I hope you get them all correct. So how do we appreciate this lesson in daily life? Similar to stoichiometric reactions, a lot of dishes require an exact amount of ingredients and spices for it to be tasty as advertised. Usually, we are guided by the recipe that provides us the detailed information on how to cook a desired dish properly. What do you think will happen if you failed to make the right estimate of what you are putting on a dish? Write your reaction in a separate sheet of paper. Let us find out if you have learned something from this lesson. Take the post test. Choose the letter of the best answer. Number 1. In a chemical reaction, the reactant that runs out first completely compared to the other reactant is the blank. A. Limiting reactant, B. Theoretical yield, C. Percentage yield, or D. Actual yield. The answer is letter A. Number 2. The limiting reagent in a chemical reaction is one that A has the smallest coefficient, B has the smallest molar mass, C is consumed completely, or D has the largest coefficient. The answer is letter C. Number 3. In the reaction between 8.0 grams of hydrogen gas with 9.0 grams of oxygen gas, which of the following statements is true? A. The hydrogen gas is the limiting reactant. B. The oxygen gas is the limiting reactant. C. 2.0 moles of water is produced. Or D. 36 grams of hydrogen gas is produced. Letter B is the answer. Number 4. This type of reagent determines the amount of the target product formed. A. Limiting reactant, B. Stoichiometric coefficients, C. Percentage yield, or D. Molecular weight of the product. The answer is letter A. Number 5. The reagent X was used in a reaction. At the end of the reaction, no amount of reagent X remained. What is reagent X? A. Limiting reagent, B. Excess reagent, C. Catalytic reagent, or D. Percentage yield. The answer is letter A. I hope that you learned something new today. Thank you and keep safe.